Okay, arithmetic sequences. Arithmetic is essentially the concept of adding, okay? And a sequence is like a pattern. So we have a pattern of numbers here, and we are either adding to move along it, or you could say subtracting, even though arithmetic means to add, but you can add negative numbers. So think of it like adding negative numbers to have an arithmetic sequence that would either go down, and adding positive numbers to make an arithmetic sequence that goes up in value. But there's a whole bunch of definitions here, or at least formulas on this side, and then the definitions to them on this side. So I'm going to kind of try to define them for you. T at n, they call this the general term. And what that is an equation to describe your pattern. So you could find any term within the pattern, and maybe I could find the next one, or 10 down the line. If I have this equation, it's very simple to do. T1 is equal to A. Well, A is called the first term. So when we look at this sequence we have below, our very first term, our A or our T1, is 3 in this case, okay? That's important to know. D refers to this value here. This is the common difference. So if we take a look at this, we could find a common difference. And again, because it's arithmetic, we either add or subtract to solve this. So we're going to take a look, and let's find out what this is moving by. We'll use the red one. 3 to get to 12. Do you know what the difference is between those two values?
9.
9, great. And we have to actually, it's important we write either positive or negative because we can go up or down. What about from 12 to 21?
Adding 9.
Again, yeah, and then, great. So it's obvious that this pattern is positive 9, even though I wrote a D here. That's a 9. Okay, so we know the pattern is positive 9, and actually I should have done this in blue because I used blue to represent the common difference. Sorry about that. Okay, so common difference. So that's important. We figured out what the common difference is. Wonderful. They've written out a couple other things here. The term number, and what a term number could be is if they ask you, oh, find the 20th term, that's where n, this is called the term number, we would change n to 20. So you'd see t at 20 is equal to t at 20 minus 1, that's hard to understand, plus d, where n is greater than 1. Okay, this is a very confusing set of equations or formulas they've given us. I'm going to try to help explain it before we actually make our general term here. So let's see, I want to find, I don't know, the fourth term. Well, we already know what the fourth term is. It's this term here. And we use t at 4 to represent that. So knowing that, that means this would be the second term. How would I represent that? T at what?
T at 2.
Perfect. And the next one would be?
T at 3.
Great. So I'm going to use a value we already know, t at 4. So I'm going to use this formula they've kind of spelled out on the side here. T at 4 is equal to t at 4 minus 1 plus, d. We have d. What is our d value in this?
9.
Great. D is the value of 9. So I'm going to just put that on the side. D is equal to 9, and we said A was equal to 3. So we already have that common information. What is 4 minus 3? Or sorry, 4 minus 1.
4 minus 1 is 3.
Yeah, perfect. So t at 4 is equal to t at 3 plus 9. Do we have t at 3? What is it?
21.
Perfect. So t at 4 is equal to 21 plus 9. What's 21 plus 9?
30.
Boom. Great. So that does work out. It's just very symbol heavy. It's hard to understand when we're used to looking at functions the way we used to write them. And speaking of that, this would be the equivalent of a function the way we used to write it. In fact, this is very similar. I'm going to bring it right back to like kind of grade 9 stuff. This is the same y equals mx plus I did the colors a little backwards, but b. Oh no, I didn't. That's good. So these are technically, arithmetic sequences are technically linear equations. The only thing is in a linear equation, we can get 1.5 for x. In this case, your n values are only whole numbers or natural numbers, like 1, 2, 3, 4, 5. So we wouldn't put in 1.5 for x. X would just be 1. What's the first term, the second term, the third term? We don't ask for half terms or a third of a term, okay? So with that being said, your general term can be turned into this function term. So we're going to build the general term since we've already written out a bunch of this stuff.
Let's go. You can see this after.
T at n
Gabriel?
is equal to, what was our a value in this one?
3.
3. So 3 plus n. We don't know. A general term is, we're not sure what term we're going to look for, so we use the letter n to represent it. But again, it could be 4, it could be 35. It's just asking which term in the sequence we're talking about. Subtract 1 multiplied by d. That is it. That would technically be our general term. So we've written it out. Oh my god, that's terrifying. That'll scare anyone who watches this in the future. How does this essentially become that? Well, when we do linear equations, b is when you cross the y-intercept. So I'm going to kind of draw it on the side here. This is where our b value is. It's when we cross y-intercept. That would also be t at 0. But if you notice, we never start at t at 0. We start at t at 1. Okay? So how would I find t at 0? Given these patterns they've written out for us here. Here's our pattern. How could I find t at 0? Ah, that's right. So we go back 9. So what would 3 subtract 9 be? Do you know? That's right. -6. So with that being said, we said that b, and I've written it out here, b is equal to t at 0, which is the same as a minus d. We just did that. A was 3. We minus 9. 9 was d. We got -6. Wonderful. How do I write this? Well, this would be the function of n is equal to d. We already know what it is. 9. Again, we use the letter n instead of x. And our t at 0 is negative. I'll write it in yellow. Thank you. -6. So, though they look really different, this general term and this like function notation, these are the exact same equation. This one starts at t at 0. This one starts at t at 1. Okay? So, a bit confusing, but let's go into an example here. I think we've put one up. Yeah, here we go. They've given us a sequence. They want us to find the 33rd term of 18, 11, 4, -3. So, what would my a value be?
18.
Great. A value is 18, also known as t at 1. Okay, we've got that. I'm going to write out the general term. So, t at n is equal to a plus n minus 1 times d. Can we figure out what d is in this case? What is d in this case as I move along?
-7.
-7, great. And we only know to move from left to right. That's how we read, okay? Technically, you could set up a pattern going from the top to the bottom, bottom up. You just have to define that to start. So we know our general term, our common difference, I apologize, is -7. So we have a is 18, d is -7. We'll easily make this general term 18 plus n minus 1 times -7. Wonderful. What are they talking about, or what variable represents 33 in this equation here when they say the 33rd term? N, exactly. So what they want us to find is t at 33 in this case, which is still equal to 18 plus 33 minus 1 times -7. Okay? Okay, let's figure this out. What's 33 minus 1?
32.
Yeah. 18 plus 32 times -7. I'm going to quickly do that on the side here. 32, 7, 4, 1, 21, 22. And it's a negative. So we have 18 plus -224. T at 33.
-206.
Hey, very good. -206. Wonderful. What I'm going to do very quickly is I'm going to make the function version of this. Remember we said f at n was equal to, I think we said dn plus b. Okay? We're going to make the function version and test it to see if it does the exact same thing. We just are missing one other piece of information for the function version. F at n is equal to -7 times n. What is our b value? Remember what b represents in terms of like t's? What would b be?
0.
That's right, t at 0. So how do I find t at 0?
You add 7.
Add 7 to 18. What would my t at 0 be?
25.
Yeah, you did this so fast. That's all right. That's the exact right answer. Good, 25. So, positive 25. Great. They want to find n at 33. So we have 33 in here, and this is how we're used to our function notation. Do you remember function notation? Yeah. Times 33 plus 25. Okay. This time we got to do 33 times 7, which actually would just be 7 more than our last answer, so it should be 231. I believe that should be it. I'm going to go out on a limb and say it's that. F at 33 is equal to negative 231 plus 25. What's that going to give us?
2. I can't speak. 2. Oh, 6. Yeah.
That's
2,
right.
6.
Great. So they're equivalent. So it didn't matter how we made it. Now, it's obviously a little easier to make this one right off the bat because they've given you some stuff. The only downside to this is it's a whole new formula to remember. This is super similar to linear equations. So if you understand how to get your b by just going back one value, it might actually be simpler to make this form the equation and then go through everything. Okay? That makes sense?